this tutorial, we deal with the possibility of coloring points based on deformation. There are two different ways to calculate deformation in the program. Variant 1 is coloring by distance by range code. That is, I choose any coordinate plane horizontally or vertically and color the points by distance to this plane. Variant 2 would be I perform several measurements in a coordinate system, and then I can calculate the distance from point cloud to point cloud. We will now deal with the first variant of area code coloring of the points according to vertical or horizontal plane. I've created a project. I am on the left of the project tree and choose an already merged point cloud. Right mouse button, load 3D model. We select the file. It is in folder mapping, image rectification, 3D laser scan Mauer. I choose my point file. I have the option to restrict the area. I go here to ortho projection, left click once, second time left click. With spacebar pressed, I can check again if I have trimmed the area too much. Could still go to the top view and deselect the meadow in front of it and behind it. And now say start import. Okay, see 3D models has a small plus. We select the point cloud, double click and activate the 3D model. And now I have here my wall with a quality of 4mm point spacing. Depending on the object, I would now have to define a coordinate system which is parallel to the wall plane, and then simply color the distance of the individual objects, the individual points to this plane. So I choose the 3D model on the left of the tree. And then on the right in the first tab card where I see 20 million points. And we switch to tab card point colors to create a new color code here. At the moment, only the color code intensity color exists. And then we create a new one and choose the type range code. We give it a name. I will call it deformation wall self. So I have to choose my user coordinate system in the first step, world coordinate system. And in the second step, I now choose an axis so I can also choose the z-axis and see what happens. Simply select the existing coordinate range in this axis and then divide it accordingly to corresponding intervals. That means if I enter here 5 intervals, I immediately see the coloring of 5 intervals. If I want to analyze the deformation of the wall, I have to choose the depth, so the y-axis. And when I look at it from above, I can see what's happening so far. It has 5 areas that are colored accordingly now. And I know that the coordinate system in this case was defined parallel to the wall. So I start here with an input range from minus 20 centimeter to 20 centimeter. Zero 0.20. Then I see my first result. All points outside of that range are now automatically disabled. So I only see the dots within this color range. And then I see here that I might have a little more reserves left. So we limit it to minus 15 centimeter to up to 15 centimeter. And then increase the number of intervals to 10. So now we have a color level every 3 centimeters. And get our result here. And then we see in which areas of the wall arches outward. I want to see this together with the rest of the data. So for this, I can create a texture combination. We go to the dialog for the display options, select the texture combinations tab, and create a new combination. Name it Deformation. And now I have two color layers. For one, the intensity color. I leave them in the background with 100% opacity, and then choose Deformation Wall South, and now have it at the opacity of 70. And can immediately choose the texture combination above for coloring. And see my result. The combination of dots colored according to intensity and the corresponding overlay with the deformation at 70% opacity. Now I want to prepare the whole paper plan in the 2D display. For this, I create a model view again. I close this dialog here and go to the left on the tree on the node model views, right mouse button, create point cloud model view. Choose first the coordinate system and then the corresponding view. Select X, Z front view. Get a proposal now depending on the point gap. I'll reduce it to 300 dpi, scale 1 to 50, and then it shows me the point distance is about 4 millimeter. And at the setting 1 to 50, 300 dpi, a pixel is about 4 millimeter in size. We say create. And if I now switch to the 2D display, I have my model view here. Menu layout, paper area. I choose my paper size A0, landscape format. Can now go on grid cross layer here in the project tree. Create a new grid cross layer. See here the coordinate system. And now we go back to the 3D display. And now, before I even deal with the 2D output, I just want to compare how does the front and the back of the wall relate to each other. That means I define for the north view of the wall a second color code for deformation analysis. So I go back to my 3D model, define a new color code, and just name it Deformation Wall North. Okay. And now, of course, we have to change the area. I'll say we start at 40 centimeter and end it at 80 centimeter. And now I get the coloring of the back of the wall. Now I have a bit of a problem. I look at it from the other direction. So all of a sudden blue is what curves outward and red is what curves inward. But here I can change the direction from red to blue so that I can just color the vulnerable area that comes towards me red. And then I can see maybe I hit the area right, or I can tweak it a little bit more. We'll narrow it down a bit to 50 centimeter depth. Then we also have a color range of 30 centimeter from 50 to 80 in 10 steps like on the other side. So again, 3 centimeter per interval. We are going back to the 3D display options because we want to see that combined and choose the existing texture combination deformation. We see my new color layer, send it also to the right and give it the same opacity of 70%. And if I now choose my texture combination here, then I can always compare them. To what extent the deformation on one side corresponds to the deformation on the other side. For example, I see here now how the wall on one side goes inward and goes outwards on the other side. That would be it for this example.